All right, welcome to Module 1, Lesson 4. In today's lesson, we're going to start learning how to actually use the metric system. And we're just going to be converting between different units of measure. Now, I'm going to show you a process that works for every unit of measure as far as metric system goes, conversions, okay? But our primary focus today is going to be using base 10 exponents again to represent that, but I'm just going to introduce you the way to convert, the easy way to convert metric systems also. All right, so let's get started. Now our standard for today is the same one, MBT12, explain patterns in the number of zeros of a product when multiplying numbers by powers of 10. Explain patterns in the placement of decimal point when a decimal is multiplied or divided by power of 10. Use whole number exponents to denote powers of 10. And that's what we're really going to do. We're going to use whole number exponents to denote powers of 10 today. Our lesson objective today is use exponents to denote powers of 10 with the application to the metric system. And we're going to talk about the metric system here in a second. The essential question, how can my understanding of the place value system help me use whole number exponents to denote powers of 10? Now the metric system, okay? This is an international decimal system of weights and measures based on the meter for length and the kilogram for mass. That was adopted in France in 1975, is now used officially in almost all countries, and is specifically used for science. And you're going to find out when you do your science projects that one of the biggest things you have to do is be able to replicate your experiment. And let's say in the United States we were using feet and inches, and over in UK someone tried to replicate yours, but they were using meters. They're not the same, so you wouldn't be able to get the same results. So science primarily used the metric system, and it is a very more exact measurement, because if you do the history of the United States, an inch was actually the length of 3 barley corns, okay, and that's like an oat. So you lay 3 of them together and that would be 1 inch. A foot was actually the average size of a Roman soldier's foot. That doesn't sound very accurate. What about the yard? What do you think the yard was? Okay, I know nowadays we say, oh, that's 3 feet. But in all actuality, the first yard was actually the waist of King Henry. Okay, that's what they considered a yard. So, these are not very accurate measurements. So the metric system is a lot more accurate. All right, so let's get started. Now here we have 2 different measuring sticks. Okay, the top one we know as a yardstick. Okay, and it's broken up into inches. And each inch is broken up into fractional parts of an inch. And it's actually, this one here happens to be broke up in halves, quarters, and eighths. Okay. Now the stick below is a meter stick. A meter stick has 100 centimeters to it. 1 meter equals 100 centimeters. Now, if you look in between, let me get my in here. If you look between, let's look between 81 and 82 here. Okay. So between 81 to 82 right here, there are actually 10 millimeters. So each one has 10 millimeters. So if there's 100 centimeters on this stick and each centimeter has broken up into 10 millimeters, that means there's 1,000 millimeters in a meter stick. All right. So as you can see, the meter stick is a lot more accurate instead of just using the fractional lengths. Now let's take a look at this meter stick. And I'm going to break this up. First off, we're going to start looking at this meter stick. And we know this is equal to 1 meter. Okay? And that one I showed you showed centimeters. And each meter is equal to 100 centimeters. Now, like I showed you, every one of them centimeters is broke up into 10 millimeters, so they're actually also 1,000 millimeters. Now, all 3 of those units of measurement, they all represent the exact same distance. We're just changing how we're representing it. We're not really changing how long something is. And that's a very important concept on this. Remember, we're just changing how it is used, not the physical length. And this is a way for us to actually be able to take large numbers, just like we saw, and represent them in smaller forms. So let's get started. Here is a saying that I like to say in order to remember this. And this is a very nice tool when you're doing any type of measurement as far as conversion with metric system. And the way I remember this is King Henry doesn't usually drink chocolate milk. Say that again with me, okay? King Henry doesn't usually drink chocolate milk. Now, it's set up like this on purpose. Now, if you notice the K, H, and D, which is kilo, hecto, and deca, those are very large measurements, okay? The U stands for the unit of measure. In the metric system, we have a couple different units of measure. We start with what we're going to be working with today is the meter. So the U could be the meter. If we were talking about how much something weighed, the mass, then we would be talking about the gram. And if we were talking about volume, we would be talking about the liter. Okay, those are the three units of measurement of the metric system. Now today, we're going to be working with the meter. Okay, so the meter is the base unit of measurement. Now, the key to understanding how to move these is all these lowercase ones are smaller. Okay, that's small measurements. These ones on the other side of the meter are large measurements. Now, the common ones we use are always going to be kilo, the meter, centa, and milli. The other ones we don't use very commonly, but they're there as placeholders so we understand. Now, I want to show you first 1 meter. Okay, if I had 1 meter, and I wanted to represent that as centimeters, what I do is I find where I'm at. Here's my meter, and I'm drawing an arrow to centimeter. Okay, and I can see from meter, I'm going to have to move this decimal point 2 places to the right. So I know 1 meter is equal to, when I move it 2 places to the right, it would be 100 centimeters. Okay. Now let's take that same measurement, and this time I'm going to represent it as millimeters. Okay. So starting from my meter, I know I have 1, 2, 3 place values I need to move that decimal point. So starting with 1 meter, and here I am, I got my decimal point right here. I'm going to move it in the direction of the arrow 3 places. 1, 2, and 3. And then I'm filling those placeholders with zeros, and that's millimeters. Now, millimeters is always represented by mm. Meter is represented by m. So now we know that 1 meter equals 100 centimeters. And 1 meter also represents 1,000 millimeters. Now let's take this a step further. Okay, let's talk about the centimeter again. So what did I do to get to this 100 centimeters? Well, if I took 1 meter and I multiplied that by 100, then that would equal 100 centimeters. Now that 100 can be represented as a base 10, because we know it takes 10 times 10 to make 100. So I could go 1 times 10 to the second equals 100 centimeters. Now that's what we're supposed to be doing in this lesson, is we are using the exponent form to represent how we're getting to the metric system. And I'm just introducing you the way how to convert. We're going to do this a lot more. Now let's look at the 1,000 millimeters. If I take 1 times 1,000 would equal 1,000 millimeters. And I know 1,000 can be represented by what? What did we learn in lesson 3? It's 1 times 10 to the third would equal 1,000 millimeters. Because 1,000 was equal to 10 times 10, which is 100, times 10, which equals 1,000. Okay, let's try something different with this. Let's say that I have 2.37 meters, and I want to represent that in millimeters. Remember how we did it? I'm going to mark where I'm at, and I know the unit up here, the U is the meter. So I'm going to put a decimal point here. And now I'm looking at wants to go to millimeter, so I'm going to draw an arrow to millimeter. Then I'm going to count how many places I need to move it to get there. 1, 2, and 3. So now I'm going to take the 2.37 meters, okay, and let me get rid of that. I shouldn't have put the M there, so we have room. And I'm going to move this in the direction of the arrow, and our arrow's right here, okay. We moved it to the right 1, 2, 3 positions. And I'm going to put my 0 in there. So now I know that this would equal 2,370 millimeters. Okay. Let's go to our next one. Okay. So let's try this one. Let's say that I had 2 centimeters. Uh-oh, get my 2 back. And I wanted to convert that to meters. Well, I'm going to start by putting my decimal or my dot on centa. I'm moving the arrow this direction. Notice it's the opposite direction this time because we're going from a smaller to a larger one. So let's see what we're going to do. Before I do anything else, I'm going to come over here to my 2 centimeters and I'm putting my decimal point right there. And I'm going to move it in the direction of the arrow 1, 2 positions. So we're going to go 1, 2 positions. Now I can see that 2 centimeter is equal to 0.02 meters. Now look at this. I had a whole number. I did something to it to get a smaller number. What do we have to do to get a smaller number? Divide, right? So I'm going to take 2 and I'm going to divide this. Now, what am I going to have to divide it by? Well, if you look back up here, how many place values did we move? 1, 2. And we know 2 place values is 100. 0.02 meters. And then we can represent this in scientific notation. 2 divided by 100, which we know is 10 to the second, equals 0.02 meters. Now we're going to go through and practice some of this. And up top, the first thing I'm going to do is I'm going to write down my code, which is King Henry doesn't usually drink chocolate milk. Okay. Now I'm coming to the first one. It says 2 meters equals 200 centimeters. They've already converted this for us. And they're wanting us to create an equation over here. Well, what did I have to do to 2 to get it to 200? Well, I know 2 times 100 equals 200 centimeters. So I know that can be 2 times 10 to the second equals 200 centimeters. So the whole key here is we're wanting to change it to an exponent form. Now on B, they haven't done this for us. We want to go centimeters to meters. So I'm going to put my dot here on centimeters, and I'm going to meters, and I can see it's 1, 2 positions. And I can see that I'm going from a smaller to a larger unit. Okay? So, and I can see by the direction of the arrow, I'm going to go ahead and solve this first because it will help me keep from making any mistakes. So I'm going to, up here, I'm going to write 108 for the centimeters. And it says I'm going to the left 2 positions. 1, 2. So that would equal 1.08 meters. Now looking at this, and I'm going to write on top this time, I know 108, and I'm going from a larger to a smaller number, so I have to divide to get there. Divided by, and it was 2 places, so that's going to be 100 equals 1.08 meters. And once again, 108 divided by 100, which is 10 to the second, equals 1.08 meters. See? Let's continue on. This time, we are going from meters to centimeters. And I'm going to do this in a different color so I don't have to erase yet. Well, maybe I will just erase to get it out of our way. All right. So, this time we're going from meters, which I don't see an M up here except for at the end, but I know meters is my base unit right here. And we're going to centimeters. So I'm drawing my arrow to centimeters. And I can see I'm going 1, 2 positions. So I have 2.49, and I'm going to go 1, 2 positions. So I can see that 2.49 meters is going to equal 249 centimeters. Now I went from a smaller number to a bigger number. So we know that 2.49, and I have to go 2 place values, so that's going to be times 100 equals 249 centimeters, which is 2.49 times 10 to the second equals 249 centimeters. All right, let me go ahead and erase so we can do it again. Now this is a great tool up top, and I highly recommend you use it. So centimeters, 2 meters, and that's 1, 2 positions. So let's solve it first. I'm writing my 50 down, and I know when there's no decimal, it's always at the end of the whole number. And it shows I'm going to the left 2 positions. 1, 2. So now I know that 50 centimeters is equal to 0.5 meters. Now I went from a larger number to a smaller number, so we had to divide. So now I have 50 divided by, and I moved 2 place values, so that has to be 100, equals 0.5 meters. And now we know 50 divided by 100, which is 10 to the second, equals 0.5 meters. All right, our next one. Now we have 6.5 meters. So we're going from meters, which is the base unit, to centimeters. And we know that's 1, 2 place values. So I'm going to come up here and go 6.3, and I can see to the right 2 position by our arrow, 1, 2. So I know that 6.3 meters equals 630 centimeters. And I'm going from a smaller number to a larger number, so I know this is going to be 6.3 times, and I moved 2 positions, so that was 100, equals 630 centimeters. Once again, 6.3 times 10 to the second, because it's 100, equals 630 centimeters. Now our last one. Now, I hope you're seeing the patterns here. This little nice thing up top that I'm showing you will work for every metric conversion. Students have a hard time with metric conversions. If they would just use this one chart I give them, they would never miss a question on it. So we're starting off and we're going to mark where we're at, which is centimeters. We want to go to our base unit of meters, which is 2 place values. So now we know 7 meters, and the 7 meters, we're going to go to the left 2 positions, 1, 2, and we know that equals 0.07 meters. So 7 centimeters, and it's going from a larger to smaller number, so I have to divide by 2 place values, so that's going to be 100, equals 0.07 meters. So 7 divided by 10 to the second equals 0.07 meters. All right, so that's it for this lesson. I hope that you learned something about how to convert metric units, but we're still just basically writing down exponential form. Okay, it's just a preview. So hopefully this will help you when we get to that point. All right, see you tomorrow.